Alright, welcome. In this video, I'm going to be working the Algebra 2 Unit 5 review. And on screen right now, you can just see kind of like a list of things that we're going to be practicing. We're going to be practicing our exponent rules, our polynomial arithmetic, our factoring, and our use of the polynomial factor theorem. Alright, so we'll start with the first one. So this goes more or less in order of the checklist on the front page. And so we're going to figure out which of these expressions is equivalent to the given expression for all values of q and w, or the expressions defined. Okay. So I'm going to start off maybe dealing with maybe going in the order of operations, like PEMDAS. Like deal with the the parentheses thing first, and then maybe I'll kind of simplify with the negative powers and see what I can do. So I'm going to have 10 q to the 5, w to the 7, times 4, and then if I square q to the 6, I'll get q to the 12. That's the power of power. We're going to multiply the exponents. Hey, I'm not going to square 4, though, because, those parentheses are saying, hey, you're only squaring that q to the 6. And then in the denominator, I'll have a 2, 3 powers of w, and then also negative 5 powers of w. When we multiply two fractions, we just multiply straight across. Okay, I'm not sure why you can't see that down there in the denominator. I wrote it in there. Alright, there we go. And now I might kind of work on top and bottom, multiplying the things that can be multiplied. So maybe I'll put the 10 and the 4 together. And then I'll put the q's together. That'll be q to the 5 times q to the 12, and then w to the 7. Divided by 2, and then if I'm multiplying w to the 3 times w to the negative 5, I'm going to add the powers. So it would be a total of w to the negative 2. And while I'm at it, I could probably multiply q to the 5 times q to the 12, add those exponents, and say, okay, that's going to be q to the 17. Okay, and then I know, okay, negative 2 powers of w in the denominator could go up here and become 2 powers of w in the numerator. And so I might do that. And then I could combine w to the 2 times w to the 7 and end up with w to the 9. And then that would be 40 divided by 2 is going to be 20 q to the 17, w to the 9. Okay, and that's answer choice B right there. And, although a lot of these problems are going to be multiple choice, I'm going to work all of them as if they were not, and then I'll just, we'll match up to the correct answer choice at the very end. If I'm not really going to be going into, like, multiple choice strategy and stuff in this video. Just thinking about the exponent rules and all those algebra rules from this unit. So over here, I might take a slightly different approach, kind of start dividing things as I'm seeing them. 12 divided by 3 is 4. And then, if you're looking at this, you could eliminate two answer choices just based on that. X to the 6 divided by x to the 2, that's where we're going to subtract the exponent. 6 minus 2 is 4. Okay, y to the negative 4 divided by y to the negative 6. We could just look at this as, dividing two powers, and we're going to subtract the exponent, so negative 4 minus negative 6 would be positive 2. And then z to the 2 divided by z to the 3, we would subtract those exponents and get z to the negative 1. Okay, looks to me like we're not, I don't see any z to the negative 1s in the answer choices, so I'm going to write that as a positive power in the denominator. So 1 power of z in the denominator, 4x squared, 4x to the 4, I just copied that down wrong, 4x to the 4, y to the 2, divided by z, and so that's that one there. Alright, these next three items are all getting at the kind of the same idea, that if we're multiplying two things that have the same base and different exponents, so like, maybe I'll even b to the x times b to the y. Okay, same base, different exponents. We're going to multiply those together by adding the exponents. Okay, so x to the 6 times x to the 8 will equal x to the 6 plus 8, which is x to the 14. Y to the 3, y to the 4, y to the 6, I'm going to compute that by adding the powers. Okay, so 3 plus 4 plus 6 would be 13. And then 7 to the 8 times 7 to the 5 is going to be, okay, keep the base the same, right? B to the x, b to the y is b to the x plus y. So 7 to the 8 plus 5, and that's going to be 7 to the 13. All right, now we're going to be asked to find the area of the triangle in terms of x and y. Okay, so we need to know that the area of a triangle is given by 1/2 times the base times the height. Okay, and we're given a right triangle, so it's pretty easy to see the base and the height. It's those two things that we're given. So the area of this thing is going to be 1/2 times the base, which is x to the 6 over 4y to the 2, multiplied by the height, which is 6y to the 5, divided by x to the 7. Now we're going to just simplify this. So I might go over here and put all the numbers together. So 1 times 6 would be 6 on top, divided by 2 times 4 is 8 on bottom. The x's, I've got x to the 6 over x to the 7. And with y's, I've got y to the 5 divided by y to the 2. And I can do this, I can rearrange these things because we know that 2 times 3 is the same as 3 times 2, right? We can multiply things in whatever order we like. That might not be true if we were looking at, like, things that were added together and then being squared or something like that. But in this case, this would work. Okay, we need a little bit more room. 6 divided by 8, that's 3/4. X to the 6 divided by x to the 7 is x to the negative 1. Okay, 6 minus 7. And y to the 5 divided by y to the 2 is y to the 3. Okay, if that's a good place to stop, then you could stop there. But if you needed to write it without any negative exponents, you could say 3y to the 3 over 4x. Okay, this next one is kind of going backwards towards the idea of negative powers of a number. Okay, so what you need to know is that 9 to the negative 3 is 1 over 9 to the 3rd power, and it doesn't have anything to do with being a negative number, having a negative power. Okay, and then at this point, I guess we would need to, kind of lean on the answer choices. Okay, 9 to the 3 is going to be a pretty big number. It's going to be a little bit less than 1,000. Okay, but it's not going to be 27 because 27 is 9 times 3. So I'm saying that I can see that's going to be 1 over 729. Okay, if I was going to put this on the test or something, I might add an answer choice E that was like negative 1 over 729. Oh no, lost that, but that's what it said. But just remember that the negative exponent, outside of having negativity on the outside of, like with multiplication, negative exponent on its own doesn't make a number negative. Okay. Now we're going to consider the function f given by f of x equals 5 to the x. Okay, so f of 0 is going to be, where I place x with 0, so that's 5 to the 0 power. Okay, 5 to the 0 power is going to be 1, because anything to the 0 power is going to be 1. F of negative 1 will be 5 to the negative 1st power. Okay, and the negative 1st power of something is 1 over that thing, so it's going to be 1 over 5. Then f of negative 2 is 5 to the negative 2 power, which is 1 over 5 to the 2 power, and we know that 5 to the 2 is 25, so I'm going to write that 1 over 25. All right, here we've got the expression x to the 34 times x to the 8 taken to the 5th power is equivalent to x to the p. What's the value of p? All right, well, I think I'm just going to work on this a little bit. I've got x to the 34 multiplied by, okay, if I take x to the 8 to the 5th, I'm going to multiply the exponents. That would be 8 times 5 is 40. If I'm multiplying two things with the same base and different exponents, that's where I'm going to add the exponents. So that's x to the 34 plus 40, and that would be x to the 74. Okay, and so since this is equivalent to x to the p, okay, the only way those two things are going to be equal is if those exponents are the same, and we'll say, all right, p equals 74. Alright, now we're going to move on to 5.2, where we started adding, subtracting, multiplying, and dividing polynomials that had, more than one term in them, that weren't just monomials. So adding, turned out it was just, stuff we'd already done in Algebra 1, it was just combined like terms. So over here, I said, alright, I've got 8y minus 5 plus 4y minus 1, I could say that's 8y plus 4y, and then negative 5 plus negative 1. So this will be total of 12 y's and negative 6. And that's answer choice D right there. Okay, and then number 11, we're going to do the same thing. We're just going to be a little more careful because they've got this thing where they're trying to trick you with the exponents. So we only have one x cubed term, it's 7x to the 3. We only have one x squared term, so it's 9x to the 2. For x's, we've got plus 2x and plus a positive 4x. And then with our constants, we've got negative 2 plus a positive 7. Okay. So these two, I'm going to be looking for 6x, and these would be plus 5. So I need 7, 9, 6, and 5. So that would be in answer choice D. And now subtraction is going to be pretty similar to addition. We're just going to start by distributing that negative sign. Okay, so we're going to look at this as, the first thing, like negative 4c squared minus 6c plus minus 6, plus a negative of negative 8c squared plus 9c plus 8. So I'll say that this is negative 4c to the 2 minus 6 times c minus 6, and then plus, when I distribute the negative to all three terms, I'll have positive 8c squared, negative 9c, and negative 8. And then we'll just proceed like we did before, where we're combining like terms. So with the c squares, I've got negative 4c squared plus 8c squared. With just c to the first, I've got negative 6c's plus a negative 9c. And then I've got negative 6 plus a negative 8. So negative 4 plus 8 would be positive 4c squared, negative 15c, and negative 14. 13, it's going to be pretty much the same. I've got 9x to the 5 plus 3x to the 7 minus 1 minus 2x to the 6. And then when I distribute the negative to all of these things, I'll have minus 3 minus 5x to the 6 minus 7x to the 7 and positive 7x to the 5. When I go to combine like terms, I'll start with the 7th power. That's the biggest thing I saw. I've got plus 3 minus 7 is negative 4x to the 7. Okay, so you could use that to knock off two answer choices. With x to the 6's, I've got negative 2 minus 5 is negative 7x to the 6. Okay, so, I know what answer choice it's going to be now, but I'm looking at the x to the 5's. I'm seeing plus 7. Wait a second, no. I must have done something wrong here. Yes, I copied down the first exponent wrong. So that was 9x to the 5 in the first thing I was subtracting. So for x to the 5's, I've got 9 plus 7 is 16x to the 5. I don't see any powers of x lower than 5, but I do see the negative 1 minus 3 would be negative 4, and okay, I feel confirmed that answer choice A is the right one. Okay, I didn't notice this. We've got one more subtraction one here. So I'm going to say that's y to the 8 minus y to the 3 minus y to the 5 plus y. Because we've got to distribute that negative to everything. So we're subtracting y to the 5 and we're subtracting a negative y. Alright, so I'm going to, okay, well I think this is all I can do, yeah. Y to the 8 minus y to the 3 minus y to the 5. So both of them need to be negative, but the y needs to be positive. Okay, yeah, here it is. Alright. Now we're going to write the area of the rectangle as a standard form polynomial. And you may not have seen the instructions come like this before, but I kind of realized that I think I've been saying write the area of the rectangle in terms of x, and we know that we're going to get an area of a rectangle by multiplying its base by its height, so it would be 5x squared minus 3x plus 7 multiplied by x squared plus 4x minus 3. And now technically I feel like this would be an expression in terms of x that would give the area of the rectangle. But, y'all knew on the quiz that I wanted you to expand that, and I didn't have anybody really pushing me on it. But I realized for the test I needed to say standard form polynomial, and that's going to be where we have it like completely multiplied out and have it, it's going to be some number of x to the 4th plus, some other stuff. Not in factored form. So I'm going to go over here and set up for the long multiplication, x squared, positive 4x, and negative 3. I'm going to multiply that by 5x squared, negative 3x, and positive 7. No, x squared times x squared is not going to be x to the 3, that'll be x to the 4. X squared times x is x to the 3, negative 15x squared. Okay, so I'm just multiplying 3x by x squared, getting negative 3x to the 3, negative 3x by 4x, and getting negative 12x to the 2, negative 3x by negative 3, and getting positive 9x, 7 times x squared, 7 times 4x, and 7 times negative 3. So I'm going to collect all the like terms. For x to the 4th powers, that's all I've got. That's 5x to the 4. X to the 3rd powers, I've got 20, and minus 3 is 17x to the 3. For x squareds, I've got negative 15 and negative 12 would be negative 27. Add 7 back, that would be negative 20x to the 2. 28 and 9 is 37x, and then negative 21. And this is a standard form polynomial. All right, now we're going to do the same thing. We're going to write the area of the shaded region as a standard form polynomial. So let's say, all right, what I'm going to do is I'm going to take the area of the large rectangle, which I might compute in red, and then I'm going to subtract the area of the interior rectangle, which I'm going to compute in blue. And so this will have multiplication and subtraction in it. Okay, so when I go to do the large area, or the area of the large rectangle, that'll be 3x plus 2 multiplied by 4x minus 7. And then I'm going to subtract the area of the interior one, which is 2x plus 1 multiplied by x plus 5. And just because I know that this is a place where you might make an error, I'm going to really emphasize that we are subtracting these products. So, you know, maybe the blue parentheses, the blue brackets will keep you from making a subtraction error. So I'm over here. I'm going to just do FOIL. 3x times 4x is 12x squared. 2 times 4x would be plus 8x. 3x times negative 7 would be negative 21x. And 2 times negative 7 would be negative 14. And the blue area would be 2x times x, 2x times 5, 1 times x, and 1 times 5. Okay. And so I might distribute that negative and get 12x squared plus 8x minus 21x minus 14 minus 2x squared minus 10x minus x and minus 5. And then I can just go to, collect some like terms. So in x squareds, I got 12 minus 2 is 10x squareds. For x's, I've got 8 minus 21 minus 10 minus 1. Okay, so that's a lot. So if I take 8 minus 21, that's negative 13. Minus 10 more would be negative 23, and minus another one after that would be negative 24x. And then with the numbers, I've got negative 14 minus 5 is negative 19. And that's a standard form polynomial that represents the area of the shaded region. All right, now this one wants us to write a polynomial that represents the volume of the prism using x. And see, it wouldn't be such a big deal on this one because, the answer choices are all standard form polynomials because, like, which of these is equivalent to the volume. But in an open response scenario, I wouldn't want anybody to, feel cheeky and want to just, say it's 2x times 2x plus 3 times 3x plus 2. So that's why we're saying it's standard form. So I'll multiply 2x times 2x plus 3 times 3x plus 2. When I'm thinking, you can multiply these whatever order you like. I might just hold off 2x until the end and then do FOIL right now. So 2x times 3x would be 6x squared. 2x times 2 is 4x. 3 times 3x would be 9x. And 3 times 2 is 6. And yeah, maybe I'll just distribute the 2x now. So the 2x times 6x squared would be 12 and x to the 3. 2x times 4x would be 8x squared. 2x times 9x is 18x squared. And 2x times 6 is positive 12x. Now I'm going to combine like terms. 12x to the 3. 8 and 18 is 26x to the 2. And then 12x. That would be this one right there. Yeah. And then a very similar one, u is x minus 3 and w is x plus 3, what's w squared times u in terms of x? Right, well, we can do that. Might do a little bit of the work off to the side here. Let's see, how much room did I budget for this one? Not enough. Alright, let's go here. So w squared would be x plus 3 times x plus 3 times u is x minus 3. Okay. Now, you can go and you can, again, multiply these in whatever order you like, but I might go ahead and grab these because I know about difference of two squares. If I multiply these, I'm going to get x squared minus 9, which will be kind of something easier to multiply x plus 3 by, rather than taking x plus 3, squaring it, and then multiplying that trinomial over the binomial x minus 3. Okay, so it'll be a little easier this way. But you'll get the same thing no matter what. Okay. Now if I do this, I'm going to... Oh yeah, I'm gonna do FOIL first. X times x squared. On the outsides I've got negative 9 times x. Inside I've got positive 3x squared. And 3 times negative 9 would be negative 27. Okay. It's a standard form polynomial, which we really haven't talked about what a standard form polynomial is, but it's where the powers are kind of descending. I would kind of switch the order of those things, but if you gave me this on an open response problem on a test or something, I'd be perfectly fine with that. Alright, okay, looks like now we got some polynomial long division. Okay. And so when we see that we're dividing by something that isn't just, x plus a number or x minus a number, I know that I'm going to have to use long division. Well, that's alright. So I'm going to set up for long division. Start by thinking, what do I need to take 2x and multiply it by to get negative 4x to the 3? So to get from 2 to negative 4, I would need a negative 2, and to get from x to x cubed, I would need 2 additional powers of x. Then I take the negative 2x squared, I multiply it by the 2x minus 3, and I'm going to get negative 4x to the 3 plus 6x to the 2. Then I'm subtracting this away. And negative 4x to the 3 plus 4x to the 3 would be 0. 16 minus positive 6 would be 10x to the 2. And I'll drop down the negative 21x. Now I think to myself, what do I need to multiply 2x by to get 10x squared? Okay, I'd need a positive 5 and 1 power of x. And then I multiply 5x by, oops, to do that down here. 5x by 2x minus 3, and I'm going to get 10x squared and negative 15x. Let's subtract this. Really going to be enough room? That's alright. I'd have to just move this up over some of the answer choices. And if I'm taking 10 minus 10, that's no x squared. Negative 21 plus 15 would be negative 6x, and I'll drop down the 22. Okay. I'm thinking, what do I multiply 2x by to get negative 6x? And that would be negative 3. So negative 3 times 2x minus 3, that's going to be negative 6x plus 9. Okay, and if I subtract this off, I'm going to get my remainder. So I guess there is enough room. And 22 minus 9 is 13. Okay, so I'm looking around at the answer choices. Okay, this is the only one with a remainder of 13, so I'm going to go with that, right? Probably good that I make sure that the rest of it matches up. Negative 2x squared, positive 5x, negative 3. Yes, and plus 13 over 2x minus 3. Now this next one, this is one we like, okay, because we're dividing by x plus 2, and that's simple enough. That's just x plus a number or x minus a number. I'm going to be able to do synthetic division on this one. So I'm going to set up for synthetic. I've got 1x to the 3, negative 2x to the 2's, no x's, and positive 4. I'm dividing by x plus 2, so I'm going to plug in a negative 2. Oh yeah, I remember why I put this one on. I liked this one because it had a missing term, and we needed to remember to put negative 2 in for synthetic division. So we're going to drop this down, multiply, add, multiply, add, multiply, add. So we've got a remainder of negative 12. That's not good. What have I done here? I see, I copied down one of the numbers wrong. Okay, so that was never a negative 2, so that should all be gone. That was negative 1x to the 2. So when I multiply, I've got negative 2, add, it's negative 3, multiply, add, multiply. There we go. Negative 8 is my remainder. I see two of these that have a remainder of negative 8, so I got to match up. Say, okay, what else is going on here? Okay, I've got negative 8 over x plus 2, positive 6, negative 3x, and positive 1x squared. So x squared minus 3x plus 6 minus 8 over x plus 2. There it is right there. Then here's another synthetic division one, and I know it's going to be synthetic because I'm just dividing by x plus 3. Okay, so I'm going to do 1x squared, positive 11x, and positive 15. I'll divide that by x plus 3, so I'll need to plug in negative 3, whatever makes the divisor 0. So I'm going to drop down that 1, multiply, add, multiply, add. That would be negative 9. Okay, I'm seeing that's the one that has the negative 9 remainder. So that's going to be it. And yeah, that's x plus 8 minus 9 over x plus 3. Alright, the next one, the area of a rectangle is given by 2x to the 4 minus 2x to the 3 plus x to the 2 minus x plus 5. Its base is given by x squared plus x plus 1. What's its height in terms of x? Okay, so to justify what I'm about to do here for you, I'm just going to remind you, we know that area is equal to base times height. And if we know that the base is this x squared plus x plus 1 expression, we could say that, and we're looking for height, we could solve for height by dividing both sides of that equation by b. Okay, so the area is 2x to the 4 minus 2x to the 3 plus x to the 2 minus x plus 5. I want to divide that by x squared plus x plus 1. Okay. And so since we're going to be dividing like this, we're going to need to use long division because we're not just dividing by x plus a number or x minus a number, unfortunately. Okay, but it'll be alright. I'm going to set up to do that long division. I give myself a lot of space between each term. Divided by x squared plus x plus 1. And this is really no different from the other ones. We just got to kind of keep our cool and follow the same process. What do I multiply x squared by to get 2x to the 4? I'm going to need to multiply by a 2, and I'm going to need to add in 2 powers of x. So when I multiply 2x squared by x squared plus x plus 1, I'll get 2x to the 4, positive 2x to the 3, and positive 2x to the 2. And I'm subtracting this all away. I'll have 2 minus 2 is 0. Negative 2 minus 2 more x to the 3's would be a total of negative 4x to the 3's. And 1 minus 2 is negative 1x to the 2's. And then we can drop down this next term. Now I'm thinking to myself, what do I multiply x squared by to get negative 4x to the 3? Definitely a negative 4, and 1 additional power of x. So when I multiply negative 4x by this whole thing here, I'm going to get negative 4x times x squared is negative 4x to the 3. Negative 4x times positive x would be negative 4x to the 2. And negative 4x times negative 1 would be, or times positive 1 would be negative 4x. Subtract all of this. I'll have no x to the 3's. Negative 1 plus 4 would be positive 3x to the 2's. Negative 1x plus 4x's would be positive 3x, and then I could bring down that positive 5 right here. And then the last step, I'm going to say, what do I multiply x squared by to get 3x squared? That would be positive 3. And then I distribute the 3 over the x squared, the x, and the 1. I subtract this all away, and this will be my remainder. And 3x squared minus 3x squared is nothing. 3x minus 3x is also nothing. 5 minus 3, that's 2. So my remainder is going to be 2 over x squared plus x plus 1. So I could say that, I did all of that, and my result was 2x squared minus 4x plus 3 plus 2 over x squared plus x plus 1. Okay, that's an expression for the height in terms of x. Here's one that's going to go a little nicer. So what value of k makes this division have a remainder of 4? And this division is just by x minus a number, so I'm going to do synthetic. So I'm just going to kind of proceed as if nothing's wrong with having k in synthetic. 1x to the 4, negative 1x to the 3, no x to the 2's, positive kx's, and minus 10. And I'll be dividing by x minus 2, so I'll put 2 in there, drop this down, multiply, add, multiply, add, multiply, add. K plus 4 is just k plus 4. If I multiply k plus 4 by 2, I'll get 2k and 8, right? Because I got to multiply both the k plus 4 and, or both the k and the 4 by 2. And then when I add these things together, I'll have 2k plus 8 minus 10 will be 2k minus 2. And then that's my remainder. Okay, if the remainder is going to be 4, and the remainder is 2k minus 2, I'll have an equation I can solve. 2k minus 2 is equal to 4. And then I'll add 2 to both sides, divide both sides by 2, and I'll get k equals 3. Alright, now let's move on and do some factoring. So which of these expressions is equivalent to 210d squared minus 63d? Okay, so I know that 21 is divisible by 7, and so is 63, because 7 times 9 is 63. So I think that but 21 divides 63, doesn't it? Yeah, because 21 times 3 is 63. So I'm going to factor out of 21, looks like. And I see d squared and d, so I can factor out that one common factor of d in both of these terms. And I'll say, what do I multiply 21d by to get 210d squared? I get 10 to get 210, and one more power of d to get 2 total powers of d. And then what would I multiply 21d by to get negative 63d? That would be negative 3. And that would be that one right there. Alright, this one is looking like a difference of 2 squares. Okay, because if we're seeing two things and they're subtracted, we're asked to factor them, it's probably going to be a difference of 2 squares or a difference of 2 cubes. And, 9n squared, that is not a cube, right? 9 is a square number, so is 25. Into the 2 power, not into the 3 power. So I could say, alright, this is a difference of squares. Okay, and this is, what's getting squared? 3n and 5 is what's getting squared. So the difference of 2 squares, that a squared minus b squared is a plus b times a minus b. So I'll have 3n plus 5 and 3n minus 5, which is that answer choice right there. Here's another one. This is a little less easy because we couldn't just multiply stuff out until we found which answer choice was right. Okay, so it says which of these is a factor. Okay, so we can go and we can do this. This is a difference of 2 squares again. I'm going to say the first thing that's getting squared is so to get 36x squared, I'd have to square 6x. And 49 is the square of 7. So this will be 6x plus 7 times 6x minus 7. And there it is. That's one of the factors. Number 27, okay, we're going to factor the polynomial completely. So I'm going to always start by looking for a greatest common factor. And I see on this one, 5, 14, and 8, those don't have any numerical factors in common. But I do see 3 powers of x, at least, in each term. So I'm going to factor out 3 powers of x. So I have x to the 3 multiplied by 5x to the 2 plus 14x and plus 8. Okay. And now I'm going to say, okay, this thing in the parentheses, is it factorable? If I multiply the first and last numbers, I would get 40. And think to myself, are there two numbers that multiply to 40 and add to 14? Yes, 10 and 4. So I'm going to go over here and I'm going to split the 14x up into 10x and 4x. And then I'm going to do group and factor. So from the first two, I'll have a 5x, be left with an x plus 2. In the second two, I've got that 4 in common, be left with an x plus 2. And then I would say this is x to the 3, factor out the x plus 2, be left with a 5x plus 4, and then we would have x plus 2, 5x plus 4, there it is right there. Okay, this one, okay, that's why it says factor it completely. Okay, so it's not untrue, it's just not completely factored because we could go farther. Number 28, okay, I look at this and I see really this is just two things subtracted from each other. Okay, two products. And so I'm looking for what's common to each of the products, and I'm seeing this m minus 6 in both of them. So I'm going to factor out an m minus 6. And what I'll be left with is a 5 from the, I'll use the highlighter here. So I've got these two things I'm subtracting. So from the first thing I'm left with a 5, and from the second thing I'm left with a negative 6m. That's looking like 5 minus 6m, there it is. It's choice A. This is really just like kind of distilling the idea behind group and factor, factoring out a binomial. So I bet this one's going to be group and factor. So we're going to factor this thing completely. And let's see, what are we looking for? Yeah, it's 4 things, so the only way we're going to be able to factor it is group and factor. So look at the first two. What can I factor out? 2 powers of x. And then, wow, 49 and 245. It's like, oh man, that's kind of a stretch on an arithmetic level, but we're expecting it to be x plus 5 when we factor it out. So I'm just going to think about what would 49 times 5 be? Well, it would be just a little bit less than 50 times 5, which would be 250, and it would be 5 less than that, so that makes sense. Okay, so this is negative 49 times x plus 5. Then I factor out the x plus 5. I'm left with an x squared and a negative 49, which is the difference of 2 squares. Okay, again, this one looks like the right answer choice, but it's not fully factored. Right, so we got to go a little bit farther. So it's x plus 5, and x squared minus 49 is going to be x plus 7 times x minus 7. And there it is. No, that's not it. That was x minus 5. Okay, gotta be careful. It matches completely. Okay, x plus 5, x plus 7, x minus 7. Yeah, that's it. Alright, so these next two are just like, here they are, factor them. So with number 30, I'm seeing 4 things added together, so I'm expecting to group and factor. So what can I pull out of the first two? That would be a 2 and 2 powers of x. So 2x squared multiplied by x plus 3. And then 8x and 24, I can factor out a negative 8. I'm realizing that all of those were even numbers, so I could have factored out the 2 at the beginning. But it's not too late. I can still work with this. Okay, and then I'll factor out an x plus 3, and I'll be left with a 2x squared minus 8. And you look at this and it's like, okay, what am I supposed to do with 2x squared minus 8? Well, factor out the 2. And then you're left with an x squared minus 4. And that's something we can work with. So I might pull that 2 out to the side. I've got an x plus 3. And then x squared minus 4 can factor into x plus 2 multiplied by x minus 2. Number 31, this definitely has a greatest common factor. Okay, I see x to the 5 and x to the 2, so there's at least 2 in both, so I can factor out x squared. But I can also factor out that 5 because 5 definitely divides 5,000. So I'm factoring out a 5x squared, and I'll be left with x to the 3 plus 1,000. Okay, if we've got only 2 terms and they're added together, the only factoring technique we've got for that is sum of 2 cubes. And x cubed is a cube, 1,000 is a cube because it's 10 to the 3rd power. So I'm going to say this is 5x squared times x to the 3 plus 10 to the 3. This is the first time we've needed to use sum of cubes, so I'm going to copy in the rule real quick. Remember that a to the 3 plus b to the 3 It starts with a and b, whether it's sum or difference of cubes. Then it's a squared, ab, and b squared, and we just got to remember what signs go in. We've got a plus sign here, so it starts off same, opposite, always positive. So using that skeleton, I have, a is x and b is 10. So 5x to the 2 multiplied by x plus 10 multiplied by x squared, negative 10x, and positive 10 squared. And I didn't quite fit that line, but there you go. That's the whole thing, fully factored. Because, and I know it's fully factored because when I do a sum or difference of two cubes, this second factor, it will never be further factorable. Okay, number 32, factor the polynomial completely. Four things, okay, we should expect to be doing group and factor. So I'll say from the first two, I've got an x to the 3 in common. I'll multiply that by x minus 5. And then negative 8x plus 40, I've got 8 common to those. But I want to get an x minus 5, so I'm going to factor out the negative 8. I factor out the x minus 5, and I get x to the 3 minus 8. Okay, x to the 3 minus 8, I can work with that. That's a difference of two cubes. I'll copy in the rule. Okay. A to the 3 minus b to the 3. It's going to be, just like before, a and b, a squared, ab, and b squared. So that's almost all fitting. Okay, and since we're starting off with a negative, because it's a difference of two cubes, same sign, opposite sign, always positive. So in this scenario, a is x and b is 2, because I've got x to the 3 minus 2 to the 3. So I've got x minus 5 multiplied by x minus 2 multiplied by x squared plus 2x plus 2 squared. Because that was... because of that. Okay, and now we've done a difference of two cubes. Okay, now this one, I made sure to put one of these on there. So on the checklist, I'm going to actually just copy this in. On the checklist, it said, I can factor a polynomial that is of the form au squared plus bu plus c, where u is an algebraic expression, and that's a little more technical than I would try to be with, explaining to y'all what you need to be able to do. This is what I'm talking about. Oh, no, that's not what I'm looking for. Yes, here we are. And so typically I say let t equal x squared. You can say let u equal x squared. It doesn't really matter. But, when I look at this, you might not think of how to factor x squared, x to the 4 minus 15x squared minus 16. But if you made a change of variables and said let u equal x squared, okay, then you'd have, I'd be able to substitute for u right there, and then u squared would equal x to the 4, and so I could substitute there as well. And then this expression would become u squared minus 15u minus 16. And this is something that we would know how to factor in terms of u. We would find two numbers that multiplied to negative 16 while adding to negative 15. And that would be, I think, negative 16 and positive 1. Yeah. And then I go and replace the u's with x squareds, because that's what u is. Okay, and then we need to realize, okay, we can work more on this, because it's a difference of two squares, but we can't do anything else on x squared plus 1, because it's a sum of two squares, and we don't factor on those. Alright, so I'm going to say x squared minus 16 is going to be x plus 4 times x minus 4. And then that x squared plus 1, I can't do anything with it, so I'm just going to leave it like that, and that is completely factored. Now 5.4 was really just an opportunity for us to, learn a little new fact about polynomials and also practice our factoring a bunch. So these first two questions, it's like, hey, is it a factor or not? I remember... just a second. Yeah, I wanted to change this one to plus 8. Big thanks to the student in my first period that pointed this out. She knew that I wanted 1 to come back, yes, it's a factor, 1 to come back, no, it's not a factor, and it was not going to work with the way I typed it in. Okay, so what we're going to do is we're going to do synthetic division, p of x divided by the factor, and we'll see does it divide cleanly or not. If it divides cleanly, I mean like with remainder 0. If it divides with remainder 0, then we'll know that this binomial is a factor, and if it doesn't, we'll know it's not. Okay, so I'm going to go over here and set up for synthetic division. 1 x to the 3, negative 1x to the 2, negative 18x, and positive 8. Okay, now, if you worked the problem as it was written on your page, then you'll get a different result from me, but, you know, that's fine. If I'm dividing by x plus 4, I'll put negative 4 on the outside, drop this down, multiply, add. Okay. Negative 4 times negative 5 is positive 20. 20 minus 18 is 2. Negative 8. Add those together, I get a remainder of 0. Since if the remainder is 0, then it is yes a factor. Okay, so I'm going to say yes, it's a factor because the remainder came back 0. Then I'll go over here, is x minus 1 a factor of the polynomial 1x to the 4, negative 5x to the 3, positive 7x to the 2, negative 5x, and positive 6. And since I'm divided by x minus 1, I'll put 1 on the outside. Drop it down, multiply, add, multiply, add, multiply, add. Yes, and then negative 2, I add these together, I get 4. And since this number here, this remainder I got, is not 0, I'm going to conclude that x minus 1 is not a factor, so no. Now, these last couple are the problem type where it's like, hey, I'm going to give you one of the factors, you find me the rest. And now this is kind of given a little bit in code, and I'm not sure if I gave it to you like this on the homework or the quiz or something, but if it says f of negative 3 equals 0, I guess maybe I'll remind you of the factor theorem. So we learned that x minus a is a factor of a polynomial p of x if and only if p of a is equal to 0. Okay? So if we know that f of negative 3 equals 0, we know that x minus negative 3 is a factor of f. So I'm going to set up for synthetic division, 1x to the 5, 1x to the 4, negative 6x to the 3, 1x to the 2, 1x and negative 6. I'm concerned with how we're going to factor this afterwards because there's still going to be 4 powers. I don't know what's going to happen here. Maybe something good. I'm just going to hope for the best. So 1, negative 3, negative 2. Negative 2 times 3 is positive 6. Okay. So we'll add down to 0. 0, add, multiply, add. Okay, I see where this is going. I was very concerned about this. Negative 3 times negative 2 is positive 6. Add those together and I get 0 like I expected. And then my quotient is going to be no remainder, negative 2, 1x, no x squareds, negative 2x to the 3s, whoops, that must be a negative 2, and 1x to the 4. And then, okay, that's the quotient, but I know that f of x is equal to x plus 3 multiplied by that. That was, at least in my sections, a big issue on the quiz. I obviously didn't do a good enough job of emphasizing in the lesson, is that when I go to factor this thing, x plus 3 is a factor, and then the other factor is, you know, kind of what we're left with there when we do synthetic division. Okay. Now, the second factor, it's kind of got a parallelism to it. It's got 4 terms. I'm thinking group and factor. So I'm going to, I think, I'm going to just, I don't have much more room. Do what I can. Okay, what kind of factor out of the first 2 terms? That's x to the 3. I'll be left with an x minus 2. And then plus 1 times x minus 2. All right, and then when I factor out the x minus 2, I'm left with x to the 3 plus 1, which is a sum of 2 cubes. I'll need to factor that. So we've got x plus 3, x minus 2. And then with the sum of two cubes, that's x to the 3 plus 1 to the 3. So same sign. Just move this out even farther. Opposite, so it's x squared, 1x, and 1 squared. Same, opposite, always positive. So, okay, and then that's going to be completely factored. That was kind of a lot. Okay, and then this is the last one. Given that p of 2 equals 0, factor p of x completely. Okay, so we know that that means that x minus 2 is a factor of p. Right, and p of x is 2x to the 3, negative 11x to the 2, positive 10x, and 8. Oh, I see where this is going. Okay, I'm glad we put one of these on there too. Wanted all the factoring types to be represented, and there's one we haven't done so far. So I'm running this through synthetic division. I've got, yes, this is good. I've divided out x minus 2. So p of x is x minus 2 multiplied by what I'm left with, 2x squared, negative 7x, and negative 4. And now, since I've got it to a quadratic, the question is, okay, is that quadratic factorable, that 2x squared minus 7x minus 4? And it will be factorable if I multiply the 2 and negative 4 and I get negative 8. If I can find two numbers that multiply together to equal negative 8, while adding together to equal negative 7, and I can do that. That's going to be negative 8 and positive 1. So I'll do that to the 7x. I'll write that as negative 8x plus 1x. And then I'll do group and factor. So I'm glad that we got one good quadratic where the leading coefficient wasn't 1. Actually, no, I think we already did this the once, didn't we? Yes, we actually did in number 27. We already did this, but it's good that we practiced this because it's easy to forget about. So in the first two, I've got a 2x common to both, x minus 4, and then if I'm trying to get an x minus 4 binomial, I'll just factor out the 1. And then I'll factor out the x minus 4, and I'll be left with 2x plus 1, and that is fully factored. And that is the entire review. That's going to be all for this video. Thanks for watching.